So learning target 1, part 1. We're going to use the explicit and recursive formulas and figure out what they are, but we're all talking about patterns. You know, adding the same number over and over again, or say you are doubling your money every day. You know, we're just talking about patterns. And then the symbols that summarize those. Part 1, explicit. Let's see if we can get this highlighter to work. All right, explicit formula. What it looks is the example 1 there. A with a little subscript n equals 3n plus 5. And that little n just represents, is it the first term? Is it the second term? The third, the fourth? And then you can look at this table and kind of see that. If n is 1, then the little subscript will have a 1. That stands for first term. And then you'd put a 1 in the spot where n appears in the formula. So 3 times the 1 plus 5. You plug it in. You're plugging in 1 for n. All right, and that gives you the first term of the sequence, 8. The second term, when you plug in a 2, you get 3 times 2 plus 5. You get 11. And then you start to see that's your sequence, 8, 11, 14, 17. Clearly the pattern is what? 8 to 11 to 14 to 17. Yeah, plus 3 every time, which is what a recursive formula uses. It uses that reoccurring pattern and defines it using that. Okay? Talk about the recursive. A recursive formula must tell you what the first term is and then tell you what to do to that first term to get the second term. So, an example of a recursive formula, it's got a little 1 equals 8. So you say that a sub 1 equals 8. And what that means is first term is 8. Then a sub n equals a sub n minus 1 plus 3 simply means you know the first term, right? You don't know the second term. In the little spot where n is. On the right side of this formula, it would say take a sub 2 minus 1, which a sub 2 minus 1 would be a sub 1, right? That would turn into a sub 1 plus 3. What's that saying to do? To find the second term, take your a sub 1, take your first term, and add 3. That's what it's saying. So your first term was, according to the definition, the first term was 8. And it's saying, take that first term, and you get your 11. To find the third term, if you put a 3 in this formula, it would say a sub 3 equals a sub 3 minus 1 plus 3, which just means a sub 2. Take the second term and add 3. So take that 11 and add 3, and you'll notice pretty quick we're building the same sequence, right? So you can define a list of numbers that has a pattern, either explicitly or recursive. All right? Now, I've got a couple of questions and then a few for you to try to get kind of acclimated with this. But the first question is, which formula would you be tempted to use? The we were just working with, the fifth term. Would you use the explicit formula, this one here, or would you be tempted to use the recursive version, and why? What do you think? Explicit, neither one's wrong. Neither one's really wrong. Explicit, I 20. But you wouldn't have been wrong if you'd said recursive either, because we know the fourth term is 17, right? So add 3 and get the fifth term to be 20 that way. So either one's fine. But what about question 2? Finding a sub 10 or a sub 100. What eventually are you going to lean more to if that's a large term? The explicit, right? Okay, so you get it. You got it. All right, find the first 5 terms of those 3. And I'll pause the videos at home. When I have you try stuff in class, I just pause the video and then start it back up and talk about them. So if you want to try it at home, pause the video with us. All right, as you can see on the screen, we talked through a sub 1, the first term in number 1. So let's talk about a sub 2, the second term. If we were trying to find the second term, we would still use the formula, square it and subtract 2, and just put a 2 in the spot for n. So square the 2, that's a 4. Subtract 2, end up with 2. Let's do a little mental math on this one. Square it, subtract 2, 7. And then running out of room. So square the 4, 16. Subtract 2, 14. And then a sub 5, square it, 25. Subtract 2, 23. All right. No big deal, right? Using them. All right, recursive. Remember the whole theme of recursive. It's a recurring pattern. They got to tell you what the first one is, and then tell you what to do to it to get the next one. So the first term, it's given, it's 20. First term, and I don't know that I put those on your sheet when I copied them. So that may have threw you a little bit. All right, I got that when I was doing the lesson the other day. So yeah, the first term, a sub 1 equals 20, has to be given on a recursive. There's the first one. Now let's find the second one together. According to the formula that's given, if I put a 2 where n is, a sub 2, it equals a sub 2 minus 1. It equals a sub 2 minus 1, mental math, a sub 1. So to find the second term, it's telling you take the first 20, the first term 20, and subtract 5. So take your 20 and subtract 5 and get 15. There's your second term. Your third term, take the 15, the second term, and subtract 5. All right, am I going too fast on number 2? You okay? Yes.
So it says in the formula, it says like if we're trying to find the third one, put like 15 plus 5.
Yeah, that's fine. Once you start to, and again, you're demonstrating that you're understanding the symbols. Once you get past the barrier of knowing what the symbol's talking about, that's 80 or 90% of the battle in this whole unit. It's just learning the language. Math is a language. You've got to learn the language. Okay? You try 3 on your own. I'll pause the video, and I'm just going to put the answers up here, and if you have questions, I'll talk about them. Okay? The a sub 1 is, that's not on your notes. 1 is given. It's 2. All right, so the little hint was triple the a sub 1 plus 1, which means triple the 2 and add 1, giving us 7 for the second term. All right, now we'll do a little mental math to find the third term. We're going to triple the previous, so now we've got a 7, triple the 7, 21, and add 1, 22. Little mental math again. I think we can still do it. Math. Triple the 22. 66. Add 1. 67. Now we may need the calculator. I don't know. A sub 5. We'll break it out just in case. Triple it. Triple the 67 and then add 1. 202. So what do you think? Using them. Yes, question. Well, when you minus the subscript, what it does is tell you to look at the previous term. So let's just talk about a sub 5, the last one we did. The a sub 5, if you put a 5 on, you do subtract 1 from the 5. So that turns into a sub 4. The symbol is saying the words fourth term. And so take the 67 and triple it. It's the symbol thing. the subscript is kind of sometimes. That's not a sub. That's pointing you towards if you put a 5 in. Take your time. It's okay. You got plenty of time to learn all these symbols, but there are a lot of them in this unit. Okay. All right. Moving on to the harder part. The harder part, page 2, the back. Part 2 is taking the formula that was given and then writing a sub n for it. Write a general formula for that pattern. All right, so there are directions. Did I start the video back? Yes. All right. There are directions that I meant to put at the top. So if you'll look down here at the bottom of your notes, kind of look to the hints that are at the bottom to help us even while we're doing the examples together. All right, first, explicit. When you're writing an explicit, you are going to end up with a formula that has a sub n and an n in it. So the first step should be put your n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5 above the terms that are there. And then start guessing. What could you do to the n that's above the term to get the term that's below it? Let's just take n equals 5, for example. The term n equals 5, the term in this sequence, the fifth term, is 2. What could you do to a 5 to make it a 2? Your first gut reaction was subtract 3. Try it for the other n's. Look at the 4. N equals 4. Does that pattern work? Subtract 3 to get your term 1? Yeah. Look at the 3. Does it work? So if it's working everywhere, you found the pattern. Every term, when I say every term, I'm saying a sub n, any term, can be found, that's an equals, whatever n you're looking for, fifth term, sixth term, seventh term, n minus 3. And there's your explicit formula. Now, I picked some easy ones for us to learn first, okay? They do get harder. But trial and error, if you're not trying hard enough, don't worry about it if you get stuck on one tonight. And by the way, perfect time to say it. If you get stuck on a problem longer than, 5 to 10 minutes, let it go. We'll talk about it in class. Your homework shouldn't take hours, okay? And if it is, let it go and bring it up in either tutoring or in class tomorrow. We'll deal with it together, okay? All right. Let's stick with explicit and try the second example. I don't recommend starting with n equals 1 because there's so many things you can do to a 1 and it doesn't really change. 5 times 1 or it's just weird. Pick a different n, like n equals 3 or 4, and play with it. I'll tell you what I think. I'm going to n equals 5, looking at the 11, and I'm thinking I'll just add 6. All right, so we'll try it over here. 4 plus 6, it doesn't work. Oh, went straight for it. Times 2 plus 1. So you tried to double it. It didn't work. But if you double the 5, you get to 10. And if you add 1, it does make 11. Yeah. All right, try the 4. 4. Double the 4, it's 8. Add 1, it's 9. Okay, seems like it's working, right? But that whole moment in time when you're thinking, what can I do to make this happen? It's okay to struggle with that for a while and play with it. It takes time. All right? But he found it. So we'll go ahead. A sub n is always double the n, 2n, and then add 1. Okay with that? I think at this point we'll keep our minds separate. Let's stay with explicit, and you try the ones that are below explicit, and I'll pause the video. Then we'll do the recursive thing. All right, and we did finish those practice problems. This is for the video's sake, so you can check your answers. If you have questions, you can let me know. Recursive. Your mind has to shift. You're no longer thinking, what do I do? You're thinking, what do I do to that previous term? What do I do to that previous term? So your first step in all of these is, what's the pattern? What's the pattern in our first example, -2, -1, 0, 1, 2? +1, right? So your pattern, recursive, is add 1 every time. So on the first term, a sub 1 is -2. And then you write the formula. Any term is the previous. Notice the subscript. That's an a sub n minus 1. That's subscript. Whatever the previous term was, +1. So this is not subscript. +1, that's not in the subscript. Look at the next recursive pattern. Think of it recursively. What is the pattern? 3, 5, 7, 9, 11. Right? So your recursive formula is define the first term, and then a sub n is previous term, a sub n minus 1. That's just a symbol that stands for the words previous term +2. Make sense? All right. Try 5 and 6. I think you won't have any problem with 5. 6 is the ones that will just always be difficult. Try 5 and 6. You can't have a recursive formula without defining the first term, so go ahead and write that down. A sub 1 is 7. It's always given. First term is 7. And then the hints on your notes, you must first find the pattern. So what is the pattern? 17, 28. What's that? Thought I heard it. Times 2. You got it. Double it. So in symbols, that means any term is the previous term times 2. So you can write that either like this, a sub n minus 1 times 2, or you can write it like this, which is my preferred. Put the 2 in front of the symbol. It doesn't matter. They are both saying the same thing. Okay? And then the last one, it's a your turn, but I'm probably going to step in pretty quick. Oh, you think you got it? The pattern. Okay. What's the pattern? All right, and that is key. +2. In fact, I need to write that on the bottom. +2, +3, +4, +5. And this is just, this is as hard as the homework's going to get, is this problem, okay? A sub 1 equals 5. A sub n equals something with an a sub n minus 1. I know that's in there somewhere. All right, now I'm going to have to take the problem and do a little more digging before I can come up with how do I incorporate the 2, 3, 4, 5? Well, what else changes by 1 every time? Right, the term, the n. The n. So I'm going to throw n's up on top. 1, 2, 3, 4, 5. And then I'm going to take one example of a previous term and see how it kind of plays out. So that would be a sub 2 equaling a sub 1. I'm just going to look at a sub 2, the second term, 7. 7. How do I get a 7 from the first term, 5? Well, what am I going to have to add to the first term? I'm going to have to add 2, right? That's a 7. That's a 5. So I'm going to have to add 2, right? I'm going to put one more up there. The third term. Its previous term is the second. So what are you going to have to add to the third term? What are you going to have to add to the second term, which is a 7, to get the third term, 10? That's a 10. That's a 7. You're going to have to add 3. Now here's the connection you have to make. That 2 is the same as that 2. That 3 is the same as that 3. And what is that letter in the recursive formula? That's the n. So your formula is a sub n minus 1 plus n. And those are the hardest because they involve n in a recursive formula. That's the end of the notes. All right. News is that